Okie dokies, artichokies, let's get started. So today we're going to be talking about a different type of data. This data is called frequency tables, and we see these quite often, especially with all the COVID data that's been coming out. Whenever you see a table regarding any kind of medical data or data on really anything, it's typically going to be a frequency table or a scatter plot, one of the two. A frequency table, basically, if you know what the word frequency means, it means something happening often, right? If you go over to a friend's house frequently, you go over to a friend's house often. So a frequency table shows how often things happen. So in this case, we have a table that is about height of corn and the type of soil that it was planted in. So you'll see if we look at 0 to 3 feet here, 150 stalks of corn grew 3 feet in the sandy soil, and 225 grew only to 3 feet in the clay soil. So that shows the frequency in which corn grows 3 feet in a different types of soil. Does that make sense? Okay. To read a frequency table is pretty easy. You just kind of have to sit down and look at it. So we're going to go over a couple things that I want you to answer on Nearpod. It's going to be a really heavy Nearpod question video because I just need you to see things and understand and read stuff. So, for instance, the first question I'm going to ask you is, how many stalks of corn grew 6 to 8 feet tall in the clay soil? Hopefully you said 250 because you would be correct. Right, 250 stalks grew in the clay soil, 6 to 8 feet. Very nicely done. If you've played any kind of Prodigy likes to throw frequency tables up for statistics. And it will often give you like a list of things. It'll say 8 people played sports but not musical instruments, 20 people played sports and a musical instrument, and you have to fill out a frequency table, just like this. Those are another type of frequency tables, the ones that have to be filled in via word problems. This one's already filled in for you, so we're going to insert some things about it. So the first thing I want to do is we're going to go harken back to an earlier lesson, and we are going to find the independent and dependent variable. I have two variables. I have type of soil, and I have heights of corn. So let's take a look. We have height of corn and soil. Which one is independent and which one is dependent, aka which one depends on the other one? I want you to think very carefully about this. Can the soil change? No, the soil can't change. The soil is just there. But can the height of corn be affected by the type of soil it has been planted in? Yes, the answer is yes, it can. So in this case, that makes the height of corn dependent because the height depends on the type of soil it's planted in, and the soil is going to be there regardless if someone plants corn in it. That makes it independent, because it could care less about the corn being planted. Yay, soil. Now that we found that out, that was just a fun little side to bring in, something we've done previously. Well, we're now going to look at something called relative frequency. Relative frequency is typically looked at in percentages. And if you know what a percentage is, if you don't know, we'll talk about it in just a second. Refocus. Come on, you can do it. There you go. Okay. But relative frequency is a frequency relative to something. So, for instance, I could find the percentage of sandy soil crops that grew 3 feet versus the total number of crops that grew in sandy soil. That would be a relative frequency, and it would be relative to the type of soil. Because I could also say, what's the percentage of stalks that grew 0 to 3 feet tall in sandy soil based on how many stalks only grew 3 feet tall? And that would be another relative frequency, but this time it would be relative to the height. So let's find both of those, okay? I want to know what percentage of stalks grew 3 feet in the sandy soil. So I'm going to take 150, because that's sandy soil 3 feet. And then in total, 1,675, so 1,675 corn stalks grew in the sandy soil. If I want to find the percentage that 150 is of 1,675, I'm just going to divide them. And you should have learned this a long time ago, so we're bringing this back. If you don't know it, then today we're learning it. You just divide it by however much they're supposed to be. So, I don't know about you, but I can't do that in my head. So, let's divide 1,675. So, that's told me that it is 0.089. 0.089. We're rounding. We're getting rid of the rest of the stuff. Typically, you only really want to go out to the hundredths. So I could round this again. Remember, if this number is over 5, you round up. If it's below 5, you stay. So because 9 is above 5, we're going to round that 8 to 9. Now you're probably looking at that going, that is not a percentage, Miss Knock. You would be correct. So the last step to turn this into percentage is to take this decimal and multiply it by 100. Now if you recall from the lesson we did on decimals, if you multiply anything by 100, it moves the decimal place back twice. Meaning that 0.09 times 100 is 9%. Which means that 9% of the crops that were planted in sandy soil only grew 3 feet tall. Sounds very smart. It's not a lot of work for that. Okay, let's try it again, but this time we are going to figure out what percentage of stalks that grew 3 feet tall happened to be planted in sandy soil. So again, we're going to take the 150, but instead of saying the total is 1,675, because that's the total of crops that grew in sandy soil, we're going to take the total of crops that grew only 3 feet tall, which is 375. Okay, so we're going to...
Well, bam! Look at all that math done! Sorry guys, my camera died and didn't tell me it was not recording anymore. So, I would have loved to show you the math here, but basically we did 150 divided by 375. That equals 0.4 times 100 is 40%. Woo! And having all this math kind of ruins the question that I asked you but did not record. Basically, this 40% makes up the 150 stalks that grew in sandy soil for the 0 to 3 feet tall category. And what I was going to ask you was, if this makes up 40%, what's the remaining percent the clay soil has to be? Well, I have that answered for you. Has to be the remaining 60%, because percentages work in 100s. So 375 makes up the remaining, or makes up 100% of all of the stalks that grew 0 to 3 feet tall. So if sandy soil makes up 40%, clay soil has to make up the remaining 60%, which is just a neat little way to look at frequency tables. It's another way to read the data. Another way to read the data is just simply an observational. And so for that, I would like you to take a look at the frequency table again. Take a hard look at it. And I want you to observe, in your humble professional opinion, which soil do you think is better for corn? This one also kind of got ruined because there's a star next to it. But let's assume that you guys said sandy soil, which is correct. There's an assumption made that, and we don't know this, but we can assume that sandy soil and clay soil planted the same amounts in each, so that we could have a nice little control for our experiment. And it looks like the sandy soil produced double what the clay soil does. If you're not convinced by that, then let's take a look at the 6 to 8 feet tall. So 6 to 8 feet tall is pretty impressive, right? That's what we would like corn to normally be. Sandy soil produces 750 stalks in the 6 to 8 feet tall, whereas the clay soil only produces 250. Let's find these percentages again, just to see. Is Because the sandy soil has produced more stalks than the clay soil has, we're kind of getting it skewed, right? This could be 750, it could be more than this purely because there's more stalks. So let's take a percentage and see if there's truly more stalks in this one based on this percentage than this one. So we're going to do sandy soil first, so we're going to take 750. So 750, and then we'll take the total number of stalks that grew in the sandy soil, which is 675, and we will divide this. Ta-da! 750 divided by 1675 is 0.4477, aka 0.45 once we round. Okay, now we multiply by 100 and we get 45%. So 45% of the total sandy soil, all the crops that grew in sandy soil total of all the crops that grew in sandy soil were 6 to 8 feet tall. So let's do the same thing for clay soil. So we have 250 divided by, there's 825 in this clay soil. And we'll do another division. So 250 divided by 825 equals 0.303033030, aka 0.30. When we multiply that by 100, we get 30%. Okay, so this is pretty definitive here. So 45% of the sandy soil crops grew to the tallest they possibly could be, which is what we want for our corn, right? The taller it is, the more corn it produces. In the clay soil, only 30% of them grew to the tallest, meaning that the sandy soil does appear to be the best, regardless of what we look at. But it is remembering to take a look at that and think about that there is more in total in the sandy soil, so what if they did accidentally plant double in the sandy soil? That'd be kind of skewed, right? You'd be like, oh, the clay soil is really bad. But maybe it wasn't. Maybe they had an unfair advantage for the sandy soil in the first place. But because a larger percentage grows taller, that does mean that sandy soil is better for the corn in general. Okay, these are just some ways to look at a frequency table. Today is basically just going to be you looking at several frequency tables and observing the data. What does it tell you? What's percentages? And that kind of stuff. That's really all frequency tables are. Just observational data. And that's it. So I will see all of you in chapter 8, because this is the last lesson in chapter 7. Woo! Anyway, have a great day. Enjoy looking at some frequency tables and enjoy some early 2020 COVID data. Goodbye, everybody. Have a great day.